So let's start with the second tutorial of unsupervised learning. Now unsupervised learning is we can create the clusters. So clustering is an unsupervised technique where the goal is to find natural groups or clusters in a feature space and interpret the input data. Clustering algorithms. A clustering algorithm tries to analyze natural groups of data on the basis of some similarity. It locates the centroid of the group of data points. To carry out effective clustering, the algorithm evaluates the distance between each point from the centroid of the cluster. The goal of clustering is to determine the intrinsic grouping in set of unlabeled data. What is k-means clustering? K-means is one of the simplest unsupervised learning algorithm that solve the well-known clustering problem. K-means clustering is a method of vector quantization, or originally from signal processing, that is popular for cluster analysis in data mining. Suppose a businessman looks for a solution with k-means clustering, and the problem is a pizza chain wants to open its delivery centers across a city. What do you think would be the best possible challenges? They need to analyze the areas from where the pizzas is being ordered frequently. They need to understand as to how many pizzas stores has to be opened to cover delivery in the area. They need to figure out locations of the pizza stores within all these areas in order to keep the distance between the store and delivery points minimum. So resolving these challenges include a lot of analysis and mathematics. We would now learn about how clustering can provide a meaningful and easy method of sorting out such real life challenges. Before that, let's see what clustering is. So k-means clustering. Now if k is given, the k-means algorithm can be executed in the following step. Partition of objects into k non-empty subsets, identifying the cluster centroid mean point of the current partition, assigning each point to a specific cluster, compute the distances from each point and allot points to the cluster where the distance from the centroid is minimum. After re-allotting the points, find the centroid of the new cluster formed. The step by step, if you see, there are so many points, data point that you can see. You can divide it in the second picture. You can divide it and then you can create two subsets. Then identify the cluster centroid. See with the red point that you are seeing on the third picture, that is the centroid. And then in the fourth you are going to reorganize it, reassign the points based on the that centroid, and then you are going to get in the last picture, that is fifth picture that you can see, it is a different set of clusters that you are going to have with centroid also in the red color. Now hierarchical cluster. In data mining and statistics, hierarchical cluster is also called hierarchical cluster analysis, or HCA, is a method of cluster analysis which seeks to build a hierarchy of clusters. The strategies for hierarchical clustering generally fall into two types. First is agglomerative. This is bottom-up approach. Each observation starts in its own cluster and pairs of clusters are merged as one moves up the hierarchy. Divisive. This is top-down approach. All observations start in one cluster and splits are performed recursively as one moves down the hierarchy. And this can be shown as you are seeing this type of graph is known as a dendrogram. Now DB scan is a density based spatial clustering of applications with noise. That is what the full form of DB scan is. A data clustering algorithm proposed by Martin Easter, Hans Peter Kriegel, Georg Sander and Xiao Wei Zhu in 1996. It is a density based clustering non-parametric algorithm. Given a set of points in some space, it groups together points that are closely packed together, points with many nearby neighbors, marking as outliers points that lie alone in a low density region, whose nearest neighbors are too far away. DB scan is one of the most common clustering algorithm and also most cited in a scientific literature. Optics algorithm. Ordering points to identify the clustering structure, that is the full form of optics, is an algorithm for finding density-based clusters in spatial data. It was presented by Michael Ankerest, Marcus M. Brewing, Hans-Peter Kriegel, and Georg Sander. Its basic idea is similar to DBScan, but it addresses one of the DBScan's major weaknesses, the problem of detecting meaningful clusters of data of varying density. To do so, the points of the database are linearly ordered such that spatially closest points become neighbors in the ordering. Additionally, a special distance is stored for each point that represents the density that must be accepted for a cluster so that both points belong to the same cluster. Now, anomaly detection. In data mining, anomaly detection, also outlier detection, is the identification of rare items, events or observations which raise suspicions by differing significantly from the majority of the data. Typically, the anomalous items will translate to some kind of a problem, such as bank fraud, a structured defect, medical problems, or error in text. Anomalies are also referred to as outliers, novelties, noise, deviations, and exceptions. Local outlier factor. In anomaly detection, the local outlier factor LOF is an algorithm proposed by Marcus M. Breuer, Hans Peter Kriegel, and then Raymond T. Ng and Georg Sander in 2000 for finding anomalous data points by measuring the local deviation of a given data point with respect to its neighbors. LOF shares some concepts with DBScan and optics, such as the concepts of core distance and reachability distance, which are used for local density estimation. Now, artificial neural network ANN or connectionist systems are computing systems vaguely inspired by the biological neural network that constitute brain. The neural network itself is not an algorithm, but rather a framework for many different machine learning algorithms to work together and process complex data inputs. Such systems learn to perform tasks by considering examples, generally without being programmed with any task-specific rules. For example, in image recognition, they might learn to identify images that contain cats by analyzing example images that have been manually labeled as cat or no cat, and using the results to identify cats in other images. Now, autoencoder. An autoencoder is a type of artificial neural network used to learn efficient data codings in an unsupervised manner. The aim of an autoencoder is to learn a representation for a set of data, typically for dimensionality reduction, by training the network to ignore signal noise. Deep belief network (DBN). In machine learning, a deep belief network is a generative graphical model, or alternatively a class of deep neural network composed of multiple layers of latent variables with hidden units with connections between the layers but not between units within each layer. When trained in a set of examples without supervision, DBN can learn to probabilistically reconstruct its inputs. The layers then act as feature detectors after this learning steps. A DBN can further trained with supervision to perform classification. Generative adversarial network. A generative adversarial network is a class of machine learning system. Two neural networks contest with each other in zero-sum game framework. This technique can generate photographs that look at least superficially authentic to human observers, having many realistic characteristics. It is a form of unsupervised learning. Now, self-organizing map. A self-organizing map, or SOM, or a self-organizing feature map is a type of artificial neural network that is trained using supervised learning to produce a low-dimensional, typically two-dimensional, discretized, representation of the input space of the training samples called a map, and is therefore a method to do dimensionality reduction. Now, self-organizing maps differ from other artificial neural networks as they apply competitive learning as opposed to the error correction learning, such as back propagation with gradient descent, and in the sense that they use a neighborhood function to preserve the topological properties of the input space. C-means clustering, aka fuzzy clustering. Fuzzy clustering is a form of clustering in which each data point can belong to more than one cluster. One of the most widely used for fuzzy clustering algorithm is the fuzzy C-means clustering, or FCM. Fuzzy clustering, also referred to as a soft clustering or a soft K-means clustering, is a form of clustering in which each data point can belong to more than one cluster. For example, an apple can be red or green. Hard clustering, but an apple can also be a red and green. So, fuzzy clustering. Here, the apple can be red to a certain degree as well as green to a certain degree. Instead of the apple belonging to a green, green is equal to 1 and not red, red is equal to 0. The apple can belong to green, or green is equal to 0.5 and red is equal to 0.5. So, that means it belongs to both the clusters. These values are normalized between 0 and 1. However, they do not represent probabilities, so the two values do not need to add up to 1. Applications. Clustering problems have applications in surface science, biology, medicine, psychology, economics, and many other disciplines. Bioinformatics. In the field of bioinformatics, clustering is used for a number of applications. One use is a pattern recognition technique to analyze gene expression data from microarrays or other technology. In this case, genes with similar expression patterns are grouped into the same cluster, and different clusters display distinct, well-separated patterns of expression. Use of clustering can provide insight into gene function and regulation. Because fuzzy clustering allows genes to belong to more than one cluster, it allows for the identification of genes that are conditionally co-regulated or co-expressed. Example, one gene may be acted on by more than one transcription factor, and one gene may encode a protein that has more than one function. Thus, fuzzy clustering is more appropriate than hard clustering. Image analysis. Fuzzy C-means has been a very important tool for image processing in clustering objects in an image. In the 70s, mathematicians introduced the spatial term into the FCM, that is fuzzy C-means algorithm, to improve the accuracy of clustering under noise. Furthermore, FCM algorithms have been used to distinguish between different activities using image-based features such as hue and the Zernike movements. Marketing. In marketing, customers can be grouped into fuzzy clusters based on their needs, brand choices, psychographic profiles, or other marketing related partitions. Image processing. Now, image segmentation using K-means clustering algorithm has long been used for pattern recognition, object detection, and medical imaging. However, due to real-world limitations such as noise, shadowing, or variation in cameras, traditional hard clustering is often unable to reliably perform image processing tasks as stated above. Fuzzy clustering has been proposed as a more applicable algorithm in the performance to these tasks, given as a grayscale image and that has undergone fuzzy clustering in MATLAB. The original image is seen next to the clustered image. Colors are used to give a visual representation of the tree. Three distinct clusters used to identify the membership of each pixel. Optimal clustering. Determining the number of clusters in a data set. A quantity often labeled as K as the K-means algorithm, is a frequent problem in data clustering and is distinct issue from the process of actually solving the clustering problem. So the correct choice of K is often ambiguous, with the interpretations depending on the shape and scale of the distribution of points in its dataset and desired clustering resolution of the user. In addition, increasing K without penalty will always reduce the amount of error in the resulting clustering to the extreme case of zero error if each data point is considered its own cluster when K equals the number of data points. There are several categories of methods for making this decision. The elbow method. The elbow method looks at the percentage of variance explained as a function of the number of clusters. One should choose a number of clusters so that adding another cluster doesn't give much better modeling of the data. More precisely, if one plots the percentage of variance explained by the clusters against the number of clusters, the first cluster will add much information, explain a lot of variance, but at some point the marginal gain will drop, giving an angle in the graph. Now, the number of clusters is chosen at this point, hence the elbow criteria. You can see the picture. It is giving a shape of an elbow. This elbow cannot always be unambiguously identified, making this method very subjective and unreliable. Percentage of variance explained in the ratio of the between group variance to the total variance, also known as the F-test. A slight variation of this method plots the curvature of the within group of a variance. And this completes the second part of the tutorial of unsupervised. So we'll move on to the last one. Thank you.